So welcome back to a brand new video of your favorite YouTuber. So today we are going to resume our original course, that is spectral analysis technique, which is a part of core signal processing technique in Matlab. So let's start. So you can see that we have to cover up these three modules, which is of approximately 20 minutes each, and we already completed the 60% part of this managed spectral leakage. So let's start and resume our course. And today I'm not going to talk very much because no, I'm not feeling well. I had a tonsils in the ear, you can say. Whenever I swallow the saliva, it's giving me a sharp pain in my ears, that's why. And also it is connected to my tongue somehow, I don't know why, but that's why I'm not going to talk too much in this session. Okay. What's happening here? Okay. Hmm. These are tiny tones. Okay. So here what we have to do is modify the beta value of a Kaiser window until FR and the two harmonic are aligned with the triangle manager. FR, which is this FR, and with the triangle mark. Uh, the tonsil is giving me a very sharp pain in my ear. What is the solution? Beta value is set up to 10. Submit. Next. Okay. Modify beta value for Kaiser window until the two peaks are aligned with the triangle. Two peaks are two peaks are aligned with triangle marks. Align in the sense what? I have to see the solution. Align मतलब क्या होता है भाई? एक मिनट, अगर इसको मैं 0 पे कर दूँ तो कैसा अलाइनमेंट मिलेगा देखने दो. ओके, दोनों ट्रायंगल एक ही पीक पे आ जाएंगे ना फिर. ओके. Next, our video is done. My net is not working well. How do I load? Yeah. I think the problem here is that I have to again go to the Matlab. इसको 0 पे सेट किया था, याद है मेरे को. So here you can see there are the different value of each functions. Then we have use the beta value to adjustable by the use of slider. Then we use this function in which the signal and the sample rate will be, sorry, the sorry, how will we store in this function? We have to look in our notes. Yes, so here the spectrum will be stored, the power spectrum, and here the frequency will be stored, and this is the function for that, where this is the name of signal, this is a value of what, window, this is the value of window, this is the value of discrete transform, and this is the value of sample rate. After that, this is the value of the, this code is for the figure, which is this.
Most signals contain noise. Vibration sensors could pick up vehicles on a nearby street. Audio sensors could record white noise from nearby machinery. Camera sensors pick up variations in light. The noise in these signals causes your spectrum to have a lot of fluctuations. If your signal contains a frequency with low power, it may be hard to see in the periodogram. To decrease the fluctuations, you can use a spectral averaging technique known as Welch's estimate. When you calculate the periodogram, you use the entire signal to calculate the spectrum. Welch's method first divides the signal into segments. Each segment is windowed separately before you calculate the Fourier transform. Then the squared magnitudes of all the spectra are averaged. Why does averaging decrease fluctuations from noise while preserving your signal? If all the power at a particular frequency comes from noise, it will be large in some segments and small in others. When the spectra are averaged together, the variance in the noise power is reduced.
Okay.
However, the signal's power is about the same in each segment, so it won't be affected by averaging.
Yes.
Up to this point, we've averaged 3 distinct segments. But if we could increase the number of averages, then we could decrease the fluctuations further. You can decrease the segment length. But if you use a segment length that's too short, you'll get bad frequency resolution. If you want more averaging without shortening the segments, you can add overlap between the blocks. When you use Welch's estimate, the window size and the number of samples to overlap can be set separately.
So we have to create the rectangular window. For that we need one function, save the 12 to the power 12 to a variable named this, and ff equals to 12 to the power 2 to the power 12, not 12 to the power 2 to the power 12. Next, set the number of sample overlaps to 0 using a variable Next, display Welch power spectrum density estimated using the inputs you have created in the previous task. The signal sig and the sample rate is this. Okay. First we need to use the signal name, which is sig, comma, Windows name is W, comma, number of overlap sample, which is this variable. If in this variable the value is stored, so we'll use this variable, comma, number of DFT points, which is NFFT, comma, FS. I also have to write this command in my notes. Okay, so signal is sig. Now save. Write it here to decrease the fluctuations in the spectrum. Use signal window FFT FS. Next, display the Welch power spectral density estimated using the default values for the Windows overlaps sample at the FTE point. Set the sample rate to this. So for this we have to use the default value, and for default value we will use a square bracket. So you can see for Windows we will use a square bracket. Overlap sample, for this also we have to use the default value, and for DFTs, which is NFT, sorry, NFFT. We also use default value. Let's see. So we will get two types of signal. You can see here. So you can see that here the fluctuations is less as compared to this graph. Sorry. Ugh. Literally. Okay. Well, we have to set the window slider so that the signal is divided into two segments. So we'll first go to max, then we will go to yes. You can see the two segments. The signal is divided into two segments. The first segment is this, and the second segment is this. Sure, jar. So for two segment, I guess 15 will be best. The slider in the script controls the number of segments that will use with village method. For example, slider set value to 2. Okay, so we have to just go on 2 and then click on submit. So number of segment will be 2. Okay. Sometimes it is too much easy, but it is difficult to understand. Divide the into 3. Next 15. Yep, 20 segments. Next. Next. Oh, so what is the value of W? It's the half of Windows length. The number of sample to overlap can be set separately from the length of the window. For example, here are the segment where the window's length is half of the signal and the overlap is 50%. see it is perfectly half. Yes, now I think we just need to complete this module and the whole course will be over. Change the slider in the script to modify the number of points. Observe how the utilization change as the length of the signal changes. We will 20 to 50. Okay, so only 85%. Subspace method. Here what we have to do, change the drop down menu up to this. So here what did we do, that we change the and the time period, or you can say the ending time period of the signal, and that's how we completed our full course. Matlab Flux catalog. You have completed your course. Congratulations. Thank you. I need to exit from this course. Then I have to collect the certificate. Then we will move towards the next course, and after that we will start to study about the operational amplifier. And after the operation amplifier is over, we will go towards the microcontroller, which is 8. Okay, I don't know the model name of microcontroller, but it is known as Intel best microcontroller. I think it's number 8051. Yes, we will have to study about this microcontroller because this is the part of my course. Next, why my net is not working? Completed course certificate, new PDF. This is my 30 certificate. 38 certificate dot 25, which will go in a certificate, math certificate. Save. Okay, certificate. Certificate dot 26 dot PDF. After this, we have to also download the report progress report, because here you can see the components that we have completed in this course. Progress report 26. So by this you can see that I have completed 29 courses out of 111 course, which is a big deal for me, because completing these courses my IQ is also developing. in It's not about IQ, it's about the knowledge. Okay, IQ is completely different thing. It is like common sense that you use in a tough situations, and knowledge is a different thing, that you know about anything, how much deeply is known as the knowledge. So I've completed this two course. Now we will go towards the time frequency analysis and filter design and analysis method. This courses consist of many things like filters, low pass filter by and bandwidth filter like that. That's why the length of this lecture is about 2 hours. So first we will go to the time frequency analysis. Here you can see the introduction, and the time varying signal is about 15 minutes, and the project and conclusion is also about the 15 minutes. But the main thing, that is Fourier time frequency analysis and Valley time frequency analysis, is of 40 minutes. So let's start the course. We will see about that later. Time management. We have to do something about the time management here. Let's start the course.
Imagine observing signals from two different seismic stations. From the first station, the signal appears consistent, almost uniform in frequency content over time. From the other station, the signal has different frequencies at different times. Frequency analysis methods, such as the power spectrum, would provide a snapshot of the overall frequency content of the signals. However, the second seismic signal is highly dynamic, with varying frequencies and amplitudes over time. So, with simple power spectrum analysis, you lose the time information. Time frequency analysis allows you to visualize how different frequency components emerge and evolve over time. This enables you to identify specific events, such as earthquakes or ground vibrations, and extract valuable information about their characteristics. Spectrogram and scalegram are two standard ways to do time frequency analysis. Both decompose the signals to a combination of simple functions, either sine waves or wavelets. The choice of technique depends on the specific characteristics and objectives of the signal analysis task. As you progress through the course, you'll better understand both techniques for analyzing time-varying frequency signals. So let's get started. Enjoy the course.
Okay, this is a course overview which will time varying signal spectral analysis methods such as Fourier transform, the periodogram, and the Blech method are designed for signal with a constant spectrum over time. For example, the frequency of a signal note on a keyboard is constant for the entire life. Um, in the sequence of keyboard note, the frequency content change over time. If you use the same method for a signal with a constant frequency, you lose the time information. Instead, use different method for analysis and visualization of the time varying signal. You will learn about this method in this lesson. Okay. Now, display the power spectrum of health gear. Set the sample rate to fs. For this, we have to use the P spectrum. Then we have to use the shift key. After that, we have to write the gear. Then we have to set the sample rate. So you can see that the values of fs is already there. So the spectrum is like this, and next step, display the spectrum of monitored gear. Okay, we have to copy paste the whole task. Then we have to replace the name of the signal, which is monitor GEAR. Oh shit, the G is in caps. Let's see. So basically you can see this is uh, 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 So this is a mat file where the value of access healthy gear and monitored gear is already there. We just need to first okay, the first module is complete, which is time varying analysis. I don't know why, but I can't read the module's perspective or the module itself because of some network issues. Also, I am thinking about that today. I am going to download a game known as Cron, which is a totally R-rated brutal game, and by R-rated I mean it has a proper bloody gameplay. That's why it is R-rated, and I like that type of game because it's give different type of experience to a user. So what we have to do here, okay, so the tab that I've just skipped is about to watch and analyze the different spectrogram. Yes, spectrogram when I adjust the slider which contain the value of some variable in the formula of a spectrogram, I guess. Display the spectrogram of the signal with the following specification. For this we will use this function, which is spectrogram. Spectrogram signal name is monitored. Window is N. There is no overlapping here, so we will skip that and we will use this. Oh, sorry. So this is our spectrogram. Does the plot is correct? Yes, I guess. But the value of N is already there, so why should I use the... Yes, we don't need to create a rectangular window. Okay, sample what is 0. Okay, okay, my bad. We have to use once N comma 1. Now it will be perfect. Next, display the another spectrum, but this time use the default value for the window, overlap, and DFT points. Display another spectrogram with the default value for window, overlap and DFT. This time visualize the frequency on y-axis. How can I do that? Okay. So to visualize the frequency on the y-axis, what we need to write a command like this: y you see there are three graphs, one, two, but this time you can see that this is rotated. So now we can see one, two, three, four type of spectrum. The next thing we are going to do is, I think it's time to learn about the YOLO model, because for ML the YOLO model is very much needed for capturing the image and processing the image. Next thing we have to do is create a 2500 point okay, so for that I need window designer. We have to go to the run. Then we have to select the windows. Yes, so the new window name is W, the type is hammering, and the point is 2500. Apply and add to workspace. Yep, it's done perfectly. Cut the windows. Oh shit. Not a problem. I will again cut this window. Display the spectrogram of a monitor gear. Use the default value of the overlap DFT and use the this default value for overlap and DFT. Yep. So our 50% code is already completed. Now we have to complete the another 50%. Now specify your output argument for the spectrogram functions called FST and PS in order. So you can see the result. Do not suppress the output by using semicolon. Suppress ही होता है, suppress नहीं होता. At the end of syntax. Okay. S, comma, F, comma, T, comma, PS. Let's say yep. Save the power spectrum at the first time instant. First line. Okay, so what we have to do here, save the power spectrum at the first time instant or the first column of PS to the variable name first slice. That's it, how to do. How to save the first column of a variable in a new variable in Matlab. सर मेरे को पता है कैसे करते हैं, वो शायद एन वैन लगता है कोलन के बाद। बस यही है, यही तो है, यही तो है, यही तो है, अरे यही तो है भाई। बी के जगह पे उनको पी एस यूज करना है बस, और इसको काट देना है, एंटर दबाना है। Then plot the power spectrum using f as the frequency. Okay. The spectrum slice comma f. How to plot a power spectrum of a signal using the signal as well as its frequency in Matlab. यही तो डाला था भाई पावर स्पेक्ट्रम का। यही तो डाला था यार। यही तो डाला था मैंने। Something is wrong, my brother. Something is wrong. Okay, so is there any other command used for displaying the power spectrum? Parallelogram, we have to use this function. Okay, this is not a simple function. First we have to write this p comma f equals to, what is the spelling, pe, parallelogram, bracket, signal name is first slice, comma, window is w if I'm not wrong, comma, and the value and tt, we will use the default value. It's w or it's default, I don't know. We will see about that later. W is not unrecognizable, so we will use this instead of that. calculation, blah 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 blah. So we will take out this. We will use a default value for window. Let's see what is the solution. Huh. You can see that to just plot the graph, you don't need to go to the spectrum analysis. F versus, sorry, first slice versus F. We need to just plot the graph, or you'll see. Oh, sorry. See the power spectrum at the last time instant, or the last column of. Let's see. Yep, it's perfect. Next. Redirecting page, sorry, rendering page. Rendering. I cannot see the page. Spectrogram output. The spectrogram does not clearly show low frequency tones such as the gear input, shaft frequency, blah 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 blah. What we have to do, display a scalerogram for the this with the stick. Yeah. So what will we do? We will use the monitored gear, comma fs. Okay, CWT is used. So this is also very much useful. CWT signal, comma sample rate. Okay. Set the frequency limit to 1000 to this. Again, we have to use this and just see. And here you can use frequency limit. I think this will give us an error. Or not. actually nothing has changed here. I can't see anything. I can just see the value here is increases, the frequency value is increased, but nothing else I can see here. Now frequency time analysis is completed about 70%. We just need to complete our 20% more, because 10% is all about the survey. Display a scaleogram of this signal using use the bump. Let's see, I think we will get an error. Yes, the bump will be after this, I guess. Nope. What is वही तो इनपुट में डाला था तो नहीं हुआ था, वो एरर दिखाए थे मेरे को. ओके, सोल्यूशन क्या है इसका? अच्छा, बम्प को इस पर डालना है. ओके 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 ओके, सॉरी 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 सॉरी. यप, फिर से कोई उतना डिफरेंस नहीं है, फिर भी फ्रीक्वेंसी की रेंज बढ़िया हो, कुछ नहीं. इसके साथ हमारा 80% कोर्स कंप्लीट हो जाएगा. Specify W and F in order as output. सॉरी. अच्छा, टास्क वन यहाँ भी करना है ना. वही फिर एंड वाला लेंगे अपन वो. Say the square absolute value of W to a variable MP. P equals to abs W. हाँ, शायद ऐसे ही लिखते, पता नहीं. मैं तो बस दिमाग लगा रहा हूँ भाई. ABS abs. भाई एब्सोल्यूट वैल्यू तो आई ना पी पर डब्ल्यू की. डब्ल्यू यही था ना. क्या गलत किया मैंने, मैं ही देखूं. अच्छा, एब्सोल्यूट स्क्वायर बोला था मैंने, स्क्वायर नहीं लिखा। अब हो गया एब्सोल्यूट स्क्वायर उसका। अभी save the power spectrum at the first time instead of the first column p to the variable name this and then plot this। सेम वही चीज़ है, कंट्रोल सी है, इधर आने का है, कंट्रोल वी दबाने का, इक्वल्स टू करने के बाद यहाँ पे क्या करने का है हमको, p फर्स्ट कॉलम, उसके बाद लेट्स सी कितना सही कितना गलत है। अबे हाउ टू लिखने की जरूरत ही नहीं ना, वो अपना आ जाता है। मेरा नेट ही नहीं चल रहा है आज। 30 FPS यहाँ पे एकदम सही है, पता नहीं नेट क्यों नहीं चल रहा अच्छे से। चल जा भाई मेरे। एक मिनट, ये देना पड़ता है कि ये देना पड़ता है, मेरे को पता नहीं। लेट्स सी भाई, इतना का सोचना पड़ रहा है, फटाफट बता दे। क्या है ना, 10 बार सोल्यूशन देखने से मेरे को फिर अच्छा नहीं लगता, मेरे को लगता है यार ये तो चीटिंग जो भी देखने से। ब्रेव का ना सर्वर थोड़ा सा गया हुआ है, तो थोड़ा एच पे देखते हैं। ओके, अच्छा ये देखे कॉमा देना पड़ता है। ओके, मैं थोड़ा सा बहुत गया था, ये देखे कॉमा देना पड़ता है, फिर बंद। अब हो गया, अब आएगा। अच्छा भाई, इतना टाइम नहीं लगता भाई रन में। पता नहीं यार, ब्रेव चल नहीं रहा, कल रात को भी नहीं चल रहा था। सर्वर डाउन है क्या ब्रेव के, क्या पता। हाँ, -0.007 का एब्सोल्यूट स्क्वायर होता है 000। टास्क करता हूँ। नेक्स्ट सेम चीज को नेक्स्ट कंट्रोल बी। हाँ, लास्ट लाइस। के साथ हमारा अब बची 5 मिनट की 2 मॉड्यूल, तो वो ख़त्म कर देता हूँ मैं, है ना। फिर मेरी एक मॉड्यूल बचेंगे जो कि मैं शायद 2 दिन में ख़त्म कर सकता हूँ। अब मैं करूँगा नहीं करूँगा वो मेरे ऊपर है, मैं कर सकता हूँ। ये हूँ यार, शिट। कुछ ज़्यादा ही अटक रहा है यार, मतलब इतना नहीं अटकता है जनरली। मैं दूसरे इस पे जाऊँ क्या, मैटलैब के इस पे। ओके, डिस्प्ले द स्पेक्ट्रोग्राम एंड यूज द डिफॉल्ट वैल्यू ऑफ ब्ला 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 ब्ला। अब द सिग्नल क्या है मेरे को क्या पता, सिग्नल क्या है मेरे को नहीं पता ना। तो ये हमारा प्रोजेक्ट है। In this project, you will compute the spectrogram from the vibration signal of a computer fan. This generated signal simulate the vibration signal using signal about 12 seconds using a critical frequency from तो यार ये दर्द इतना हो रहा है ना कान में, दिमाग खराब होता है। अरे यार कंट्रोल जी। डिफॉल्ट वैल्यू फॉर विंडो ओवरलैप एंड ये ना, नहीं बे। अरे क्या प्रॉब्लम है, ओवरलैप एंड विंडो। अबे सही तो डाला है। अच्छा स्पेक्ट्रोग्राम, यार मेरे को सच में दर्द हो रहा है बहुत। क्रिएट दिस काइदर विंडो विद विंडो डिजाइनर रन। खुल जा भाई मेरे, खुल जा खुल जा खुल जा खुल जा खुल जा। What we have to do, we have to create a 2048 point Kaiser window। काइजर चाहिए भाई, काइजर। 2048 नेम रहेगा W। value of beta equals to 19. Apply, save to window, then cut it. This is the default value of blah 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 blah, but this time we have to use w here, submit. Next, change the y limit to zoom into the spectrum between this and this. तीन से 5. मेरे नाक कुछ ज़्यादा ही बह रही है. मेरा रुमाल पूरा शेमड़ा हो गया. ऐसा लेना पड़ता है भाई, नाक पर डाल के जला दो. Okay, the next thing we have to do here is, अरे यार, specify 4 output arguments. S comma F comma T comma PS. Which it's only save the power spectrum in the name of first lies. ना सब एक साथ ही मारते तो दिमाग खराब. लास्ट लिखना है ना. दोनों ही कर दे. चाहे भाई जो कर सकता है कर ले, एरर देगा शायद. सॉरी यार. तो ये लास्ट और ये फर्स्ट. डिस्प्ले द स्केलेरोग्राम फॉर दिस. जिस वाला उनको सी वाला यूज करना है, CWT वाला. CWT यहाँ पे जाएंगे. सिग्नल का नाम है मूव कॉमा इसके साथ आई थिंक ये कोर्स खत्म हो गया। नहीं, अभी तो 85% ही हुआ है। नहीं, हो ही गया भाई, हो ही गया, हो गया, हो गया। एग्जिट कोर्स, लीव। बाबा हमको हमारे सर्टिफिकेट दे दो भाई, सर्टिफिकेट मांगते हैं हमको। देख, अभी अब भी शुरू किया और अब भी खत्म हो गया। जब तुमको थोड़ा बहुत आइडिया हो पहले से तो बहुत इजी जाता है। मैं बोलूँगा कुछ ज़्यादा इजी हो जाता है कभी कभी। कभी कभी कुछ ज़्यादा ही हेक्टिक हो जाता है कि तुमको पढ़ना नहीं होता, तो कोर्स थोड़ा सोच समझ के लेना। इसी के साथ भाई मेरे ख्याल से इसके नेक्स्ट वाला करूँगा तो 28-30 के आसपास हो ही गए मतलब मेरे। हैं? कुछ तो गड़बड़ है, 2 मिनट होगा। प्रॉब्लम हो जाएगा ना बाद में फिर। मैथ सर्टिफिकेट 24, 25, 26, 27, 28 है। अच्छा, यहाँ पर रिपोर्ट 28 है। सर्टिफिकेट कौन सा ही है? ओके, ये वाला एक सर्टिफिकेट है, ठीक है। टाइम एनालिसिस का है जो कि अभी अपन ने किया। टाइम एनालिसिस, ओके। 27 ये हो गया। इसको लेंगे कॉपी, पेस्ट, रीनेम। तो तुम रिपोर्ट देख सकते हो, 1 से है 27 तक। 28, 29 मैंने एक अलग कोर्स किए वो, और 30 अभी कर लेंगे थोड़ी देर में। 30 प्रॉपर सर्टिफिकेट रहेंगे, और 3 एक और सर्टिफिकेट जो कि बताता है कि सब में मास्टर ये हो गया है। तो भी कर लूँ क्या? लेट्स सी कितना बड़ा कोर्स है भाई। 25 मिनट, 1 घंटा 15 मिनट, ना ना भाई। इसको अपन को 2 घंटे का है तो इसको मेरे को तोड़ तोड़ के करना पड़ेगा। तो फिल्टर एनालिसिस में लगेगा अच्छा खासा टाइम। फिर आर्बिट्रेरी रिस्पॉन्स, फिल्टर डिजाइन एंड एनालिसिस, इसमें भी टाइम लगेगा। फिल्टर स्टेबिलिटी में भी टाइम लगेगा भाई। आई गेस इसको 25-25 तोड़ के करना पड़ेगा, जो कि हम कल शुरू करेंगे और शायद परसों या नरसों खत्म कर देंगे। और एक बार अगर सिग्नल खत्म होता है, सिग्नल के कितने कोर्स है देख लेते हैं एक बार। 14 कोर्स है, जिसमें से अपन ने 1, 2, 3, 4 ये भी कंप्लीट कर लूँगा। है अच्छे खासे कोर्स अभी। और ये वाला भी करूँगा ना, बस सिमलिंग फंडामेंटल्स। इतना ही बचता है। सिग्नल सेगमेंटेशन विद डीप लर्निंग, जो कि डीप लर्निंग के साथ करेंगे। स्ट्रीमिंग सिग्नल क्या होता है पता नहीं, तो मैं नहीं भी क्या तो भी चलता। ये वाला एक बार देखना पड़ेगा, बाकी लगभग हो ही गया है। आउच। मेन तो जो ये वाला कोर्स है हमारा, ये हो जाएगा तो फिर मेरे लिए एक टाइप से सिग्नल प्रोसेसिंग जो है वो हो ही गया। यार, क्या लगा दर्द है। तो उसके बाद मैं जाऊँगा फिर नेक्स्ट जो है हमारा सर्किट ऑन रैम्प। देखो मैं दिखाता हूँ। इसके बाद ये सर्किट सिमुलेशन ऑन रैम्प, जो कि फिर से बड़ा है थोड़ा सा, ठीक है। इसके बाद तब पावर सिस्टम्स में जाएंगे, अलग अलग सिस्टम में घुसेंगे और सिमुलिंग फंडामेंटल भी करना है मेरे को। और अभी क्या है, सिमुलिंग आ गया तो मेरे को नहीं लगता मुझे ज़रूरत होगी, है ना। और क्या बताना था, हाँ मेरे कोर्सेज तो मेरे शायद 30 हो गए, यहाँ पे दिखा रहा है ना, 30 कोर्सेज हो गए मेरे। और बड़े बड़े कोर्सेज हुए तो मैं क्या था बोल सकता हूँ कि अच्छे कोर्सेज हुए। तो आज के लिए इतना ही, मिलते हैं नेक्स्ट